record, so.
Is there a way to make this a permanent lake or reservoir or something like that? I mean,
No,
what
I
would be the
wouldn't
process
advise
for
that, and I think, because that's, the block that is slumped, it's not intact by any means. It's a chaotic, disturbed mass of Green River formation. And it's, I mean, you can just, it's more like a soil than it is rock right now because of the disturbed nature. So it's highly unlikely that that would be something that could remain a permanent type reservoir.
You said 700 to 800 acre feet off the top of your head. Can we compare that to anything for people who have no idea what an acre foot is?
Well, that was based on a volume, a triangular volume that was 1,600 feet long, 300 feet wide at the top. So an inverted triangle, you know, along that whole 1,600 foot length. That's 100 feet deep, 300 feet wide at the top. And that's kind of what we, because the way that it's back tilted, it's not rectangular. It's more like an inverted triangle as far as the cross-section geometry of the interior.
Why can't you go in there and cut a channel that would then let this water flow out?
Well, you'd have to have somebody on the material, which is, you know, that's dangerous in and of itself. That amount of material would take a significant amount of earth moving, and if you were to decide to try to remove it by blasting, you would have to get up there. You couldn't just set charges off at the surface. You'd have to drill holes, and actually it would be almost like a production blast in a quarry. So you're on material which is inherently unstable. So, I mean, if we're not going to let people search underneath it, we're certainly not going to let people on that mass.
You said that you know that this will fail, but do you have a timeline?
I certainly don't. That's the inherent problems with hazards like this, is that of those three scenarios, the worst that I can think of is that it fills up with water and sits there for years and years and years to the point where people forget about it. And then at one point in time, we might have another, you know, significant rainfall and it were to breach, and then we'd have flooding extending all the way down, Salt Creek. I mean, that's the scenario that's a possibility.
So potentially, how many houses, how many people are beneath that would be affected by a
Well,
like
that's really not a question for me. That would be a question more for the hydraulics people here at the county. And you'd have to look at what would be the peak discharge, and there would have to be some calculations there, and that would be more for flood control people.
How unusual is this, if it is at all?
The type of landslide is unusually big, but they're pretty common. The Grand Mesa is ringed by landslides, and that's the nature of this weak type of formation. So really, the perimeter of Grand Mesa, all the way around, is mantled by landslides. So it's not unusual. What's unusual is just the size.
Is there a possibility that another landslide could fill in this depression instead, and then there wouldn't be this concern with pooling water and there would just be more land in there?
I guess it's possible, but we saw no evidence of any tension cracks up above in that. You see the tree line above there. And it would fill with rubble, but you'd still have the inherent problem with a saturated mass of disturbed landslide deposits that could mobilize.
Just to go back real quick, I mean, exactly what we're looking at here, this kind of tree line and where there is a snowpack, there's not a concern of that coming down? Or you just said you did not see cracks in that area?
We did not see cracks. If that were to fail at this point in time, it would just end up in that depressional zone. You talk about a retrogressive failure, an oversteepened slope, and then it starts failing back on itself. And that's possible, and we did see, even during the time we were up in the helicopter, sloughing off. But I think that's what we're looking at there, would just be minor sloughing within that depression. Not anything that could generate this type of failure.
Energy companies are working below this slide. Could that have in any way contributed to maybe the size of this slide?
I don't think the oil and gas drilling had anything to do with this slide. I don't see how it could have.
So we can get John back up here for other questions if you have them. I want to go back to the pictures that Ben is cycling through here. If you could start over, Ben, I want to point out a couple of things on our pictures. So this is what the Google Earth picture or the satellite imagery looks like with prior to the slide, and we've mapped in a rough area of what that looks like. And then the next slide demonstrates what we were able to do, overlay it with imagery that was stitched together from the UAV yesterday in that activity showing the slide. The beauty of this is that in addition to just showing what it looks like before and after and using that technology, is that we also are able to, within a fairly consistent degree of certainty, understand how deep this is at different places. And what we've learned is that even out here on the edges of it, we're more than 30 feet deep in most places, and in the middle, it gets deeper and deeper, and in some of these areas, it can be up into the hundreds of feet deep. But the point being is that this is really bedrock, earthen material, rock and dirt. It's dry down here, and it's extremely deep in areas. This thumbnail or thumb pin here represents an estimate only of really where we believe the three people may have went to do their investigation of what was causing irrigation water down in these ranch lands to dry up. We're not confident that that's exactly where they were, based on conversations with the family about where they were going and what they were doing. We believe they took this road that comes down off of here and would have wound up down in the bottom of here. How far they were going to go up to investigate the slide that occurred earlier in the day, we simply do not know. It's probably safe to say, though, that whether they were here or whether they were up in here somewhere, the debris flow would have brought them down into this area. So it remains an area of interest to us as a priority to continue to search. You want to play the video, Ben, real quick, just the first part of it? So this video, I think, is some of the best pictures of sort of the volume and size of the slide. It gives you some perspective of really how far it is. You want to just pause it right there. This is, of course, the breach up here. This is this mound, huge mound of dirt that we're concerned about sloughing off and coming back down, and then this shows the slide coming down. This is the hill that demonstrates the velocity of the slide itself. It came down in a straight shot and came up a hill behind here and then over the top of this piece, and then it kind of went down and around. So the power of the slide itself was enormous. And what we're concerned about is if that basin that's behind there fills up with water, the drop here is 2,000 feet from the top to the bottom. If you have that material plus it full of water, you can see that coming down on top of this existing slide goes all the way down, kind of comes around the corner from this little ridge. What we would be worried about, and this is what we really are going to be doing in the next weeks, is what is the threat assessment to this coming down? Would it fan out into these fields? Would it continue to go down Salt Creek? Those are just questions that we don't know, and I'm not sure that we have the kind of crystal ball that will tell us for sure. But what we will want to do is work with the USGS and the United States Forest Service, our county partners, and anybody else that has expertise in monitoring this so that we can detect movement, detect another slide, set up early warning systems if we need to, start talking